More than 90% of the Earth's soil will be degraded by 2050, according to the World Soil Resource Report. Soil and the fungal network it contains are the second largest carbon recycler and are a great ally against the climate crisis. Evolutionary biologist Toby Kiers is the co-founder of the Society for the Protection of Underground Networks, and it's also known as SPUN, and she's on a mission to map the world's fungi in an attempt to help fight climate change. So, Toby, I guess the best place to start is what exactly is a fungal network and why are they so important?
Well, underground, there's this massive circulatory system that we call mycorrhizal fungi, and these networks exist because plants feed them carbon, right? So some 5 billion tons of CO2, carbon dioxide, is fed into these fungal networks. And in exchange for the carbon, the fungi provide nutrients like phosphorus and nitrogen, and they sort of have a barter economy. But as the fungi are being fed, this helps bring CO2 levels down and helps limit global warming.
What is entailed in actually mapping these networks? Because I imagine there are thousands and thousands of them.
To start mapping fungal networks, there's a couple of things we have to do. We can't obviously go out there and measure centimeter by centimeter. So what we do is we use these algorithms, right? It's like a machine learning algorithm, and we feed data into these algorithms, and they help us predict where these hotspots of biodiversity are underground where we can't see them.
What specific data sets are you using to find these initial locations and begin the mapping process?
So we use remote sensing data, right? We have hundreds of layers of information all over the earth about the ecosystems, how much rain there is, what the temperature is. And so we've got hundreds of these layers. And then we couple that with samples of soils that have been taken in the past where the DNA of these fungal networks has been extracted. And if we put those two pieces of information together, we can start predicting where are the unique habitats where these fungal networks exist where we haven't been before.
How difficult is it? What are some of the challenges in mapping these networks?
You're using these algorithms that basically take you to all corners of the earth. We just came back from an expedition in Chile, and the algorithm had us going in very sort of wild ecosystems. At one point, we had to try to cross a swing bridge to get a point just on the other side, but the bridge would have collapsed under our weight. So again, you can't really predict where the algorithm is going to take you.
Are there any surprises that you've learned to date from gathering the information and mapping these networks?
What we're trying to do is work with local collaborators to understand what networks are doing what. And so I think the biggest surprises are going to come from ecosystems that we don't necessarily know are harboring the most biodiversity. So take, for example, you would think maybe it's the tropical rainforests that harbor the most diversity because that's what happens with plants and animals. But actually, our predictions show that for certain types of fungi, grasslands harbor huge amounts of diversity. And tundra in the northern boreal forest hosts a lot of fungal biodiversity. So again, all of these surprises about where the fungal networks, where that diversity of mycorrhizal network exists.
After you've mapped enough of these fungal networks, how is this information going to help reduce climate change?
Well, I think for us, the real hope is that we start putting underground systems on the map. I think that there's been this bias in conservation and climate agendas for above ground ecosystems. But below ground ecosystems, they store some 75% of all terrestrial carbon, right? This is the major stocks of carbon are underground. And so I think we're going to be successful in sort of leading a mind shift, a radical mind shift where people begin to appreciate these underground ecosystems and fight for their protection.
It's interesting you mention rainforests. We all understand the importance of the Amazon. So have you found the Amazon of the underground?
And that's why we need to get more what we're calling underground astronauts or myconauts excited about this underground exploration because we don't know where the Amazon of the underground is right now. And so we really want to stimulate people to think about the underground differently. I mean, a single handful of soil has about 100 meters of this mycorrhizal network and billions of different kinds of bacteria and protists and all kinds of soil life. There's so much to explore below ground We just need to develop the tools and the global vision to get that done.